Good morning. Good morning. God, thank you. This is spring session. Thank you for being here with us this morning. How many of you are cold? That's why you don't react when I say good morning, because you're too cold? Come on. So I'm Alvaro. This is Bruno. Joel is online.
Hi, this is Alvaro. I am Bruno. Should we start? Okay. So welcome to Spring Working Group. We have a full agenda. This is the nutshell. This is a set of rules so that we can work together nicely. And there are rules about the internet standards, working group process, anti-harassment procedures, code of conduct on IPR, copyrights. So you're supposed to know all those. If you don't, please read. Same thing in more details. Nothing really new, except if you're in the room, you need to log in. And if you want to join the queue, you need to join the queue with the application. And if you're remote, please close your mic if you don't want to say anything, just to have nice audio quality for everyone. The minutes are online. We can all contribute, so please help. Specifically, if you go to the mic and say something, please check that your comments are correctly reflected. And also, please correct your name because it may be misspelled. We are in the process of recharting. You have the URL to the main discussion. Current status, it is within the ISG, and we have there was a telechat, ISG telechat in November, and so far we have one block remains. I lost the network. Okay, so I lost the network. Can you take over, Alvaro? Well, maybe I will recover sometime. I'm back. Okay, yeah. In terms of working status, so we progress on service incorporation. So nice work. Thank you for all the work done, especially the editor on Shepherd. It's currently in RC editor queue. Another document is draft IETF Spring CSSR policy. Working group last call has passed. We may be pending some IPR replies from contributor. Thank you to the Shepherd, Liu Hayao. And the status is that the Shepherd review has been sent on the list. I believe we are pending replies from the others. Another document is draft IETF Spring BFD. Working group last call ended in December. The status is inconclusive because we only received one reply from a non-author. Next step is for authors to reply to the review, especially direct reviews. And then we'll start another working group last call. And finally, this is the agenda for today. We have a full agenda. Any comment on the agenda? Any agenda matching?
No changes to the agenda, but I just wanted to comment that there is a lunchtime event in this room after we finish. So we have to be out at 11:30. So please, let's stick to the agenda. We can have discussions as we need them, but we're going to have to cut everything at 11:30.
And next is our document about SRS6 security. I should be able to pass you in a few minutes.
Thanks. So my name is Tal Mizrahi. This is an update about the SRv6 security considerations. And the previous version of the draft was presented in IETF 121. So this is kind of a list of the main changes since the previous version of the document. So there were a few various text updates related to various issues. We won't go over all of them, just a highlight of the main ones. So one major change was regarding terminology, and we're going to go over that change in a little bit more detailed in the next slide. And another change was related to address filtering, and specifically regarding RFC 9601, regarding the SID address space. So the text regarding address filtering is now more detailed, more accurate, and specifically regarding the point of how to use RFC 9602 addresses. I don't know if this works. Next slide, please. Okay, great. So a few more words about the terminology, and generally speaking, in terms of threat terminology, we distinguish between internal and external attackers, where internal attackers are within the SR domain. Obviously, external attackers are outside the SR domain. And there's also a distinction between on-path and off-path attackers, where an on-path attacker can either intercept traffic or modify it in transit. So these are terms that were already used in the previous version of the draft. What we've added in the current version is a distinction between data plane, control plane, and management plane attackers. And this distinction is important because, for example, when we combine these different terms, we can think about on-path attackers in the context of data plane, or on-path attackers in the context of control plane. And it has a different meaning because these different types of attackers have access to different types of information or different aspects that they can potentially harm. So this is the taxonomy that we're going to use. And so these are the main changes. And this was with regards to a specific comment we received in the previous IETF meeting. Next slide, please.
You can control.
Okay, great. So we adopted a set of milestones that the working group chairs suggested. And what we're focusing right now in the last couple of months was updating the terminology. This was the main focus in addition to other changes we've applied. And we're still open to any comments regarding the terminology. This is something that we're currently hoping to kind of close. And the next milestone in the next 2 months is going to be to iron out the aspects related to the data plane. So actually, I think we're in relatively pretty good shape in terms of the data plane. The document so far kind of focused on the data plane. So, but we still hope to close all the details related to the kind of attacks and mitigations that are specifically related to the data plane, and hopefully that can be closed in 2 months. The next milestone after that, towards IETF 123, will be to work on control plane aspects, which is something that is mentioned in the current draft, but has a relatively short subsection. So we're hoping to include more details related to the control plane attacks and mitigations. And the next milestones after that will be management plane aspects. And then hopefully by IETF 124, we'll have pretty full draft, which includes all the content we intended to include in this draft, and will be open to final discussions and comments. So these are currently the suggested milestones for the upcoming few months. So like I said, we're open to any suggestions, either as messages on the mailing list or directly to GitHub. Feel free to send your pull requests, and we'll be happy for any kind of suggestions and comments.
Tom.
Knocking things over. Hi, Tom Hill from BT. I was curious about the updated text in 7.1.3, the address range filtering, where it states that some examples of an infrastructure address range for SIDS are number 1, ULA, number 2, the prefix defined in 9602, and 3 GUA addresses. Is that intended to be an ordered list of preference?
Yeah, I'm not sure. This wasn't text that I specifically wrote.
Okay.
But if you can send that question on the mailing list, then we can.
Yeah.
Nick will reply to that.
Okay, no, that's no problem. Thank you.
So before you go, just a couple of reminders. This, or actually, I'll let Drew ask the question before.
Hi, Dhruv here. Thanks for the update. It's looking good. One comment I have with respect to adding the NMS in the figure and focusing on management on path attack. So where does PC fits in? I think it would be much better to say, are you thinking PC is part of that NMS? Is it something else? And when you say control plane, my mind thought of like, more distributed control plane. But if it's PC, like more explicit, where is it in your terminology and the threat model? Thanks.
Okay. Yeah, thank you.
Yeah, thanks, Roof. So I just want to remind everyone that one of the reasons we're doing this work is because the IESG asked for it. And so we want to finish it as soon as we can. That's why we came up with that plan that Tal showed in the previous slide about moving a little bit faster and with purpose, right? So we will have an interim meeting of the working group in May at some point. We'll figure out a date that hopefully works, and it'll probably be at the magic 14 or 1500 UTC time that usually fits most of the people here. So we'll announce that with plenty of time so that everyone can plan on it. Please read the document so that we don't just have the presenters talking about it, but that we have actual interaction, because that's what we need, right? We need working group engagement to move anything forward. And the last thing I wanted to mention is in this slide, there's a link to the GitHub. It's fine if you want to interact there, but please make sure that all the discussions are somehow reflected on the mailing list, because that is where the working group works, right? So we want to make sure that there are no, that there are public discussions, not just discussions on the GitHub, because not everyone uses GitHub or is going to follow that. Besides the fact that that is Nick's private repository. So we want to make sure that everyone is aware of everything that's happening. Okay, thank you.
Thank you.
So in case you're wondering, we're playing a little bit with Mirako here. We're having a little bit of trouble.
Hi, I'm Himanshu Shah, presenting on behalf of my co-authors here. Eligibility concept in SR policies. So, next slide, please. Oh. So what is the eligibility attribute? It is a new concept we are proposing here in this draft. It is associated with the candidate path. And this flag actually determines if a candidate path is eligible to carry the service traffic. If it is set to true, then yes, it is eligible. If it's not, if it's false, then it's not. So when is this check done? So you have RFC 9256, which tells you that you have an initial creation of the SR policy with a given intent and multiple candidate paths. And you have preferences in the candidate path. So you use that to select the particular candidate path. You validate it. You have make sure it is operational using the SBFD or the stamp or whatever. And at that point, post all these checks, you want to make sure that it is eligible to carry the service traffic. So this check for eligibility is done at that time. It's an additional check that you put to this, you use for activating the candidate path. So the check is done at the head end, because head end is the one which is Ingress PE who's going to do put the service traffic onto the SR policies. But it is not necessary that head end is the one who has to reset the flag. A PCE controller, operator, anybody can reset the flag or set the flag for that matter. So why? What is the purpose of the eligibility? So eligibility actually represents the preservation of intent. Even when the seed list is created initially for based on that intent, the intent may, the post the creation, there may be changes in the network. In some cases, the seed list is optimized, it's compressed, and you can have changes into the network and the intent is not preserved. So you want to add this additional check to make sure that the eligibility check is that the intent is preserved before you start putting the service traffic. Now, there are, what kind of changes in the network can happen? I mean, of course, there is a failure, but you could also have, without failure, some traffic engineering characteristics changing, like an affinity or the cost that may affect the SR policy seed list that you have created for a given candidate path. because of those, it may not meet the original intent with these changes into the network. The other one is the delay. You could be experiencing um, uh, uh, changes into the delay. End-to-end delays may not satisfy the original intent that you had created at the time of the when you, at the time when you did create the network topology was different because of the traffic and other things. The delay can vary, and end-to-end delay may not meet the original intent. Now, so in this case, the seed list could still be operational and active, but intent is not preserved. So we'll give some example. One of the example is this, the link failure. So in this, on the left, if you see, you have an original path created through A, B, D, E, Z. Now, and that's the candidate path 1. For the backup, it is going through A, C, F, Z. You have made sure that D, Z, D, F, Z. You have made sure that going through these links, you have the resources reserved, the bandwidth, and all of the stuff, and you know that it meets all your intent criteria. Now, obviously, you know, the optimization or compression of the seed is, so in some cases it's necessary because you cannot have all the seed hops be expressed in a seed list. So in this scenario here, you have the seed list BZ, and you have made sure that the path it's still taking is going through from B to E via the D, and B to D and D to E links are preserving the intent that you have created, your original intent. Now, if there is a failure, in this case, a link between B and D fails, then you know, the IGP would automatically, or FRR would automatically switch over using the BGD. Now, you had not anticipated that for the bandwidth reservations or other resource allocations, and that is not meeting your intent. So in this scenario, the intent is not met. You want to modify your eligibility. So headend would immediately set the eligibility to false and do the failover to the alternate path where it has reserved all the resources. Now, you continue to check with the topology changes and all that, whether the alternate path that is going through because of the topology change, is it meeting your intent or not, or you wait for the link to recover. And at that time, PCE would change the eligibility to true, and then you will switch over, revert to the primary. The other example is delay. As was mentioned, you use temp for checking the delay end to end and see if it is meeting your intent. At the time of creation, it was, but it got deteriorated and it is failing. So you set the eligibility flag, cause the switch over to the backup candidate path, continue to monitor, and as and when the original intent or the delay parameters are met, you set the eligibility flag again on the primary candidate path. The reversion would then occur. It could be either immediate, it could be with a hold off timer, it's based, or no reversion based on whatever user has configured. This is just an implementation choice. So those are, now in this case, in delay sensitive, nothing has changed as far as original path is concerned, but the intent parameters got compromised because of the change in the delays. So That's the reason to also make a candidate path ineligible to carry the service traffic. So this, as the summary is that it's a very general purpose flag that for intent verification, and it's not tied to a specific use case. I gave a couple of examples, but there are many examples actually that we have seen and has been proposed as a in this working group. This eligibility flag can be useful for those. So the final, we want to propose to have this document be accepted as a working group draft.
So far, go ahead.
Zafar, Cisco Systems. So I have a few comments. One is that you have two different ways of doing this eligibility check. One is you talked about local, and one is PCE. So on the local, there are other drafts in this working group, at least two that I'm aware of, that talk about this. Some of these criteria are based on if you run PM on a per SL basis, how many PMs should go for it to be compromised SL, and you switch over and attributes checking and all. So that's one aspect. But the other aspect which you bring in this draft is the PCE that can also make something ineligible. And there, what draft is to have is that what is the local versus this remote interaction? Because what can happen is that local process is running and it figures out. Let's say you give the delay example, right? In the delay example, the local entity doing it.
Yeah.
What is PCE doing in those cases? In the other cases, when you talked about FRR, maybe the local process doesn't do it. It's PCE that this, but there's this interaction. Like, what is this interaction? When, what happens? Because then you have not two entities taking same action, right? So that clarification.
Can I respond to that?
Yeah.
So I think basically you are saying that there are multiple actors setting and resetting or modifying the eligibility flag, and then how do you coordinate those things, right? So the head end is set it, now how PC, how does he know he would set it or reset it, and when that thing all happens. Now, that's a good point. We have to work out all those details. The original intent is that the purpose of this draft is that there is this additional eligibility or intent check before we get this thing. Now, in terms of who sets it, who resets it, whether operator he wants to manually switch over from primary to candidate, primary candidate path to the backup because he wants to put things in the maintenance mode, or he doesn't want the backup candidate path to be in maintenance mode and not to carry traffic even if the primary fails, right? All other stuff that has been there, use cases, you can use this with the eligibility. Now, how you synchronize, right? How you make the PCE aware that the flag is already false, how the PCE then would set it to true and all that stuff. I think we'll have to work on it, all those things.
Yeah, and then I have another just comment. So there are two different types of like at least two drafts which talked about local eligibility check in the local box in terms of performance, whatever data is collected, verification.
Yeah.
And there's one draft that talks about like NMS based action on these CP. Let's say it was in IDR working group that there was discussion on shutting a CP, which is another action which is similar to what you are saying from PCE. So that is another aspect that needs to be sorted out.
Yeah. So there is a Yang, BGP, PCE controller, the operator man through CLI and all those things. They can all set it, reset it. I think those things are has to be added. Actually, we do recognize that that work is still pending. I think this was the original idea here, was to make sure that there is an additional check through the eligibility attribute or this conduit, is that we have that in place so that all these other use cases that are being they are talking about having a different ways to do for each use case. Okay, so I think what we wanted to do, and I think this is based on the working group feedback we got, including yours from the previous other draft, that this is generic enough and can be applied to many other use cases. So that is the starting point here. All the additional details still needs to be added.
We need to move on.
Okay.
Thank
So-
you. Let's talk offline. Thank you.
Please, let's talk about it on the list. Boris, really quick.
Yeah, Boris Hasanov, MWS. I read the draft and I got motivations behind it. Two comments. First one is there is mentions compressed seed list.
It's coming up next.
Yeah, but you know, it's immediately stick SRH compression. So maybe additional comment needed, like specific clarification for your case, what to differentiate it with SRH compression. First comment. Second comment, and I think it's more important, this eligibility concept brings very significant change to RFC 9256 active CP choosing. So I am concerned what we will have like this foundational RFC which defines SR policy and candidate path activation process, and now we bring additional ship in the night concept. So in my point of view, it also question to the chairs, maybe we will need like some RFC 9256 bis in the future, because later on where we can bring another like SR policy application which will bring additional criteria for which will modify CP selection process.
So I think it is an important, I think we did feel that this is an important concept that we need to put forward. It has, in addition to the regular checks that we do for validation and preference and all that in selecting a candidate path, we can, I think your comment is that, hey, should there be a BIS that should address this? We are open to any of those things. I think that it is what we do want to sell you is the need for an intent check or intent verification as an additional check to what we already have a criteria to select a candidate path.
Yeah, that's clear. I'm just saying about like clear consistency between like RFC 9256 and CSSR policy, which is subset of overall SR policy. So we need consistency. If we define some additional attribute, we change, it has to be reflected in the base too.
Yeah, you need to be rolled in so everybody can see along with that. Yeah, main draft. So I mean that I'll leave up to the guidance from the chairs. The whole intent initially is to be agree with that. Yes, this additional check is necessary.
Right. So yes, consistency is important. I know Ketan has opinions on this as well, so we can discuss this on the list. Asian, you're next. We have 22 seconds.
One question. You know, if the link failure or the delay exceeds the threshold, I think the head end of the path so that they calculate the path. In your example, the original path is active, but it does not meet the requirement. So I think why don't you remove the original path directly but use instead of using the newly defined flags. So if we move the original path out of the cached path, then the traffic will steer the new path that can meet the requirement. So why you don't move the original path directly?
I'm not 100% sure because of what your comment was, but I'm guessing
Mm.
What you are saying
Mm.
is that you can modify the original seed list instead of having an eligibility flag or use the eligibility flag to make sure that that path is not being used.
I
that-
was saying on the list for the more.
Yeah. Send it on the list.
Yes,
So it
there's
would be
also,
more-
Himanshu, some comments on the chat. There's another draft in IDR that maybe you want to go take a look at, and some other comments and questions there. Please take a look at that. And
Yeah. And I think that is the main point, is that there are multiple drafts with a different use cases are suggesting a different ways to do these things. So that's why all these the co-authors felt that this actually this okay, this is a next segue to that discussion. So we originally, this CSSR with optimized seed list is a use case on which also uses this the eligibility flag. And so I will address to that. It's hard to read from here, so I'll go from here. Yeah, so we've been talking to many service provider operators. There are some service provider operators who wants the path nailed down at every hop for certain type of applications, like satellite operator or utilities, and they are very transport centric operators, and they need to have a predictable behavior. So, which is why they were actually using the MPLS-TP. They moved from the transport to and the packet world, and MPLS-TP was giving what they really wanted with guaranteed resources, predetermined path, traffic steering, and all that stuff. And they would have a primary and backup and all that. So segment routing was the right technology for them. Again, the next step for them is to use that newer technology instead of MPLS-TP. And so this need for this nailing down the path of every hop has been recognized by this Spring Working Group and have adopted a circuit style proposal. And it's almost in the last call by Christian. The problem with that is that it uses the persistent adjacency seeds for the entire path. That has a tendency to blow off the MSD, especially when you have a low-end access router, which are the ingress PEs or the head ends, which uses the SR policy, and they may not be able to handle the label depth. Now, yes, there is a result. You can resolve that by sprinkling the binding seeds at intermediate hops, but that makes it more cumbersome. At what other places, P routers, you have to put those binding seeds and manage them. So we thought about that, and we said, well, if we were to use a compressed seed list, if you can optimize that and reduce the seed depth, the seed stack that you have to use, then, but at the same time, you have to make sure that between the seed hops, the IGP SPF hops you are taking, it is going through the links that you are expecting the original, which meets the original intent. So this is where the compressed seed list comes about. And this draft was presented by Amal in IETF 119. Now, in that particular draft, we introduced this eligibility attribute. We got all the feedback from the working group, some of the folks here, and said, look, this is generic and can be used by many other use cases. Let's take that out from the draft and progress that separately, which is what we just talked about for the eligibility concept. And it is decoupled from all different use cases. And the whole idea then is that let's have all other use cases, and there are several of them that can use this eligibility flag. So we took that out and we updated the CSSR version and refers to the eligibility draft for getting the CSSR done. Now, I have the original slides. I can go over them if necessary. Or I think mostly what I want to just I can go over the example. The two cases that I would, we talked about the initial creation and what happens if you have an compressed seed list, and if there is a failure, your intent is violated and you want to, how do you handle that, right? So we talked about that particular case, but I think the one point I do want to um, is the additional point is that when you are doing that computation in the PCE or the controller, uh, you also need to take into account of the links that are down while you are creating your compressed seed list. And this is an example of that. The link from while you are creating the seed list based on the original intent, the link at that time between B and E was down. So if you were to just have a seed list which is BEZ, yeah, it will take the path from ABDEZ, and you are okay with that, with the compressed seed list with the BEZ. However, if the link was to recover between BEZ, between B and E, now your intent would be violated because you didn't reserve the resources, the bandwidth resources or any other resources on that link. So you want to create the seed list that takes into that account a priori, and instead of BEZ, you have the BDEZ for this particular example in topology. So you have the PC has to take that into consideration as well.
Safar, you have a question?
Zafar Ali from Cisco. I am one of the authors of the circuit style draft, and I implemented technology. And I can tell you why it was not done this way. And the reason is this, that if you use node sets and not adjacency sets, then you have this issue that FRR can kick in, and we use unprotected for that reason, because we have path protection and you want the path protection to kick in, not FRR. Now you remove that with the user node state. Now you can have FRR, and then you run into two issues. One issue is that your local, which was supposed to do path protection, would not detect the failure. Second is that you took the traffic on detour path where you never did booking. So you are in unbooked environment. Now you're trying to solve that problem from PCE telling, oh, you have FRR, so you go and you switch. So the problem that started is by not using the unprotected agency state, and I believe is architecturally incorrect. You should not do a race condition between FRR and path protection. Bandwidth booking also goes off the track, but more importantly, I'll say that your assertion that binding SID is cumbersome is very implementation specific. You give example of compression. In compression, I have not seen any issue in terms of not being even able or needing a transit binding SID. I think the right way to solve this is just use transit binding SID. This is architecturally how SR policy architecture defines it. I think it's very implementation specific what you're talking about. And in SRVC micro like compression, there's no issue in terms of need for the compression for the binding SID.
Yeah, I think this has been discussed also in the past. You have to inverse the timers. We are not asking for as TILFA be disabled on every node in order to do these things, right? What you do is you have a more aggressive end-to-end path SBFD timers as compared to the TILFA single hop based on single hop IP BFD. So that way you would fail the end-to-end path fault is detected first before the TILFA takes over and let the path continue right? So that's that way. And by the way, we have implemented this and deployed it for a couple of operators. So it does work with the compression and the inverse timers for end-to-end protection versus the local fault. Um, so that was your first point with respect to. The other thing is that going back, so this is again your fully specified uncompressed seed list, and having to sprinkle the binding seeds everywhere. It is cumbersome because there are many excess nodes that goes end to end all over the place, right? And where you put those binding seeds, what characteristics it has, because your access nodes are not capable of full uh, pushing the entire set list. So it is, I mean, that to use persistent adjacent seed for the entire path, there is there is no novelty in that, right? Anybody can do that, and that's, there is nothing new there. You can always do that, right? The only difference is that how you can make it better, so that you can include all other nodes, all type of topologies. Yeah, go ahead.
Can you respond one? I think this is not good. You slow down the whole IGP convergence by going the link detection slower, so your path protection can win. I think this is not right. And the other thing is that with compression, I have hardly seen anybody needing a binding seed. So, but binding seed is maybe cumbersome for you, but it's not for others.
So this is a fascinating discussion. Greg, we close the queue.
So I'm out.
Yes. Please take that question and the discussion
Put it on
to
the
the
list,
list. It would be
yeah.
wonderful if you continued the discussion so far on the list and not just let's
Yeah.
wait until the next IETF to.
Yeah.
Talk about it
And
yet.
I mean, we welcome your comments, and we have talked about this in the past as well. So we'll continue those discussions for sure. Thank you. By the way, what I want to emphasize here, okay, again, is there
So
all
we
this
need
threshold.
to move forward.
Okay. But I
Thank
think
you.
there is a next one is presentation is going to talk about something similar, different use case
So
and
let
different
them-
flags.
Let them talk about it. Yes. Thanks.
Okay. Thank you.
Hello everyone, I'm Yisung Liu from China Mobile. Today I will present the flexible candidate path selection of the SR policy. I will, on behalf of my co-authors from the H3C, Huawei, ZTE, and Verizon. For this draft, the background is that one CP maybe have multiple SLs, and one of these SLs is invalid, and the remaining SLs may not meet the performance requirements, such as the bandwidth or the latency or the packet loss rate. For example here, it's obvious. I will not introduce in detail. And this draft will give a proposal for the validity of the candidate paths, and we will set the threshold of the parameters for the candidate paths. And when the SL can meet the forwarding quality and the resource, we can think that the SL is valid. And if it cannot meet the forwarding quality or the resource requirements, and we think that the SL is invalid. So next we'll give the more detail of this. For the threshold, of the segment list level, like the jitter, the latency, the packet loss. And when the SL, we can set the threshold for every SL for the threshold for this type of the parameters. And when the SL cannot meet the requirements like this, we think the SL is invalid. But for the for the second type, like the bandwidth, we think the summary of the present preset the bandwidth for the remaining SLs, if not meet the requirements of the bandwidth, we think that the CP is valid or invalid. This is the a simple use case for the bandwidth and the latency for this proposal. In the left, we have a CP1. CP1, there are 3 SLs, and every SL can meet the requirements that the 100 megabytes. And we set the threshold of this CP is more than 150 megabytes. If 2 of the 3 SLs happen to a failure or other things cannot work, so the remaining SL, only one remaining 5 SL can contain the bandwidth for only 100 megabytes. So the CP1 is not valid for the service traffic. So we'll think that we will switch the active CP from the CP1 to the CP2. For the right use case, and there's only one SL in this in the CP. So when the CP cannot meet the latency requirements, and we will switch the CP from the CP1 to CP2 if there are more than one SL. And the SL, maybe we have a SL1 and SL2, and SL1 cannot meet the latency requirements, but the SL2 can also use. But so secondly, we will continue to see the bandwidth for the CP1. It can, if the summarize of the remaining SLs can meet the bandwidth requirements. If commit the requirements, we will still use the CP1. If not, we will switch from the CP1 to CP2. So for this draft, we have the first presentation in the IETF 117. And after the presentation, we have updated the clarification for the threshold on the segment list level and the candidate path level. And also at the parameters like the PAM, referenced by the IPPM working group document. And also at the use case based on the E2E latency. And after IETF 119, thank you for the comments for the mailing list. We add the clarification to clarify that this proposal only add the validate of the candidate path. It will not change the rules of the path selection preference as defined in the RFC 9256. it will not change the segment routing architecture, policy architecture. So next steps, we will welcome more feedback, and we also think the draft is ready for the adoption call. That's all,
Himanshu,
thank you.
go ahead. You have a question?
Yeah, so this is precisely the point I was trying to make at the end of my presentation. Again, Himanshu Shah from Siena. This is a use case, and there are many other use cases, compressed or this threshold based, bandwidth, delays. Yesterday, there was another draft we talked about energy. Whatever your intent and T criteria are, those are all the use cases where you apply this eligibility, and so those use cases shouldn't be defining a different way to how you can switch over from candidate path 1 to candidate path 2 or whatever. You check your intent. If intent is not met, you invalidate the CP, CP1 or whatever the active CP is at that time with an eligibility flag. Just want to say that there is a many use cases of that. And this is just another use case.
Yeah.
Thank you for
Yeah.
volunteering to working together with all the other authors on getting some consistency here. Ketan.
Ketan Talaulikar, Cisco, as author of RFC 9256. So we have the tie-breaking rules in the RFC, which are strictly governed by the operator that is provisioning the SR policies. They could be via BGP, PSAP, on CLI. They are completely strictly in the control of the operator. They are very static in nature. Then we have the validation rules in our RFC, which are about the path being down, the SID being not available in the topology, the interface going down, whatever can be detected on the head end. Now, what we are adding is extra more qualitative checks, which could change dynamically based on network conditions and all of that. This is something, in my opinion, this is something additional. And that's why I like kind of the eligibility proposal. Now, whether we call it eligibility or something else is up to the working group, but it's a additional criteria or like a check. And all of these are use cases for that. There is one more draft I've also in Spring Working Group. So again, my suggestion would be that to leverage this eligibility or something else framework, and everybody can use that. That way, this updates the RFC 9256. I don't believe there is a need for a BIS.
Yeah, I think that this is just a selection policy for the how to active the CP, not the selection rules. Yeah.
Sure, I can also kind of summarize this on the list.
Okay.
Thank you.
Thank you.
Boris, go ahead. We already locked the queue in case you're trying to get on it. So, Boris.
Yeah, Boris Hasanov, very short comment, just maybe repeating what Ketan said. We need consistency with RFC. So if it says just active segment list exists, CPs exist, here we bring addition. So we need somehow to manage with consistency as in previous case.
Shraddha Hegde, Juniper. So my question is, this eligibility criteria or whatever additional validation that you're doing, is it only when you initially PC installs the path and you're selecting the paths, or it's on the router it is continuously being evaluated so that at any time the eligibility, there's some change in the path and it's not eligible, and so you bring it, you reselect?
Oh, we have discussed with the draft author with the eligibility. We think we can align with that draft. Our proposal also think that the CP if the CP is not invalid or the SR is not invalid, it will now not steal the service traffic in that. But the state of the CP or the SR is still up for available. So we have the similar concept for the intelligibility.
No, my question was with respect to the additional qualities of the path you are checking, whether delay or whether it meets that threshold or not. Is it continuously evaluated or only once? That is my question. Continuously.
Yeah.
Okay. Okay, he says it's continuously monitored. Yeah.
Okay.
Thank you.
Yeah. We will continue to monitor.
Thank you. Sheng, we close the queue, so we'll leave you for next time. Please take it to the list. There's definitely a lot to talk about between the different authors of the different proposals, use cases, however you want to call them. And please do that on the list. Thank you.
Thank you.
So we're going to move on to our next presentation, which is Bruno.
Thank you. So Bruno from Orange. I'm going to present a short draft to define a new type of segments to perform aggregation for SRMPLS. So what's the problem statement? For IP, we can do a route aggregation on routing border, typically ABR for IGP, yes, but also between IGP routing domains sometimes. On aggregation, it's a key property of IP routing. And the main gain is some scaling improvement in FIB, in control plane, and in terms of churn. You can easily have a 2 order of magnitude gain in those aspects. However, for SRMPLS, you do not have the ability to do aggregation. So you cannot profit from these gains. So they drive to propose to define a new type of segments. We call it aggregation segment, specifically for SRMPLS, to allow for summarization on routing border from a control plane standpoint, so typically IGPs, and to do MPLS hierarchy in the data plane, so that we can have a single FIB tree for all the IP MPLS routers on ingress and transit area. So that's the goal. Let's have a look in more details what the SRMPLS aggregation segment would be. It would be a segment which would represent two things at the same time. First, the aggregate. So for example, /24 for IP. That would represent the prefix segment for the summary. And then we have a second hierarchy to advertise all the specific segments, so the /32 for IPv4, which are being aggregated by that summary. And as far as the data plane is concerned, we also need to advertise two labels, one for each. So one label for the summary. We use it 2000 for the example. Next slide. And then for all the specifics, we would advertise a range of labels. So for example, a range of 200 labels. It's a bit similar to the type of signaling we do with the mapping server, but for a completely different use case. Speaking of use case, the first typical use case, the more complex, is inter-area scenario. I'm using ISIS terminology, but it's likely the same for OSPF. So we have three routing domain. In the middle, we have transit. We call it level 2 in ISIS. And we have two areas. Let's call it area 1 on the left, which is the ingress 1, and area 2 on the right, which is the egress 1. So we want to set up traffic from PE1 on the left up to PE3, PE2 on the right. So what's new is an ABR2, which is performing aggregation. So it has a set of specific in its area And it's only advertising one summary address, let's say a /24. With that summary, it advertises one label for that prefix, aggregation prefix. And then we need to advertise all the more specifics, and we aggregate that when we summarize that with a range. So we advertise the first prefix in the range, the first seed or labels to be used in the range, and the size of the range. So that's the work of ABR2 doing aggregations. It's typically configured by the operator, which is handling the addressing plan. And in terms of signaling, ABR2 is typically redistribute that advertisement in the ingress area. So that's for signaling part. In terms of data plane, so all the nodes in ingress and transit area would only install the summary prefix. So with one label, which is 2000. And for ingress, who have a specific need to reach P2.1, for example, so P1 would selectively install the prefix seed, the more specific prefix seed for P2.1. And it would push the two labels hierarchy. At the top level, it would be the summary to send the packet to ABR2. And at the bottom level, it would be the specific one from ABR2 to P2.1. So most of the work is on ABR2 doing summary, but on ingress, we want to be able to understand the new signaling and selectively install what we need. Next slide is a different use case. So we do inter IGP instance. It's mostly the same. It's simplified because we only have two domains. Everything else is the same. Something interesting in both cases, but is that you don't really need to install any new labels. For example, for BR2, the labels that you advertise on IGP1 are the same labels that you have already installed from your IGP2. So for example, it's 1201. So even the node doing aggregation do not need to install new fib entries to do the aggregation. It's doing re-advertisements in a compressed form of the fib entries it's already using. So what we want to achieve is to hide details, so summarize. This comes with benefits and disadvantage. So in terms of benefits, it's mostly scaling. In terms of fib, control plane, and churn. But we have to know that this comes with limitations. Mostly you hide the details about each PE or each prefix seed. So you lose the reachability, you lose the end-to-end IGP metric. Both of these are not new. If you do IP aggregation, you already have the drawbacks. And you lose also some data that you may want to signal with its prefix seed. So for example, IGP prefix tag or prefix flags, and specifically the entropy level capability. That being said, for the reachability, we have a new draft and an ELSA working group to advertise IGP unreachable prefix announcements, aka UPA, which allows signaling unreachability of the remote, the egress PE. So we don't completely lose the signaling of unreachability. In terms of operational constraints, so you need everything to be aggregatable in terms of IP address, in terms of seed, and also IP to seed mapping need to be allocated in order, such as if you allocate seed 1 to IP1, for IP2, for IP1 plus 1, you need to allocate seed 1 plus 1. So that's the restriction for aggregation. In terms of the draft, we've restricted that all the specific prefix need to be of the same size in terms of prefix length. Typically, it would be a loopback. We also allow for a single level of aggregation. So if you do multiple areas only on the egress ABR. And finally, there is a question of redundant ABRs, because typically you have redundancy. So far, we use anycast advertisement, which come with anycast considerations. There used to be a draft in the working group about that, but it became dead because finally the industry chose to have configurable sRGBs on all nodes. But the comment on the draft on the mailing list said that maybe we need to change the sRGB during a network merge or for any operational reasons. And in which case, at least for some period of time, you have an inconsistent sRGB on the two or the multiple redundant ABRs. So that's something that need to be discussed. Do we want to use anycast advertisement or not? I think we can do both, so it's up to working group. And finally, we got some few initial reviews and comments. So thank you especially to Robert on that. We'd like to solicit more review and comments, and then we'll publish a 0.1.
Martin, go ahead. I blocked the queue because we're running already a little bit late.
Martin from DT. Just to make sure I get it right, this leads to all PEs doing a double push instead of a single push.
Yes.
And
all PEs using, yes.
Yes. So that means all the PEs in the network would need to do this. Otherwise, I cannot profit from the better scale in the PE routers.
Absolutely.
Okay. One more question. Did you consider whether this would work with LDP stitching?
On what part? On BRs or anyone? On ingress? Or?
Well, typically, if a PE does not know about SR and PLS, but uses LDP, perhaps the BR would do the stitching. So the BR would then have to do another push and get it all together. Did you consider this yet, or would that still be to be discussed?
Definitely not yet. We need to consider that. Thank you for the comment.
Thank you, Bruno. So we're going to move on to our next presentation. This is Wataru.
Hi, everyone. I'm going to talk about SR-basics SFC architecture with SR-aware functions. Next slide. Oh, okay, sorry. Okay, let's start with our motivation. We aim to get the comprehensive management and simplicity of SR-basics SFC. First, comprehensive management. We want to apply SR policy. It includes QoS and SFC with PCEP, and we want to bind specific flow to SR policies and with BGP flow spec. We want to correct service segment network functions information from BGPLS extension, and also we want to correct topology information from BGPLS. Next, second is simplicity. In our architecture, there are no SFC proxy. So as a result, it's reducing the number of nodes and address resource consumption. This figure shows our architecture's brief. And this figure shows our architecture's detail. These are standardized or standardizing protocols. BGP flow spec with SR policies classifies the target flows as the SR source node. PCEP and BGPSR policy deploys the SR policy to SRv6, SR SAS mode, and BGPRS collects link state data. BGPRS service segment extension also collects service segments. A PCE receives this link state and service seed from these service function node and SR, as a SR node. And its compute SR policies include SFC and applies with PCEP. In this version, we have revised the SR service segment manager. After VNF manager or some BIM components sets up a network function, the service function manager deploys the service segment to service function node. PC retrieves service segment information from service segment node. It's not communicate to other managers directly. We joined this IETF hackathon and implemented some standardizing protocols. First, we implemented BGPRS advertisement of SR service routing, segment routing service segment. We implemented the BGPRS extension to some BGP daemons, and we also implemented the Wireshark dissector. And the second, we implemented the BGP flow spec extension and PCEP color TLB. We can deploy the SR policy with colors from PCEP and to PCC, and we also send to the binding encapsulation policy with BGP flow spec extension. Then, at the next, we plan to implement the other controller component or data plane implementation. This is one of our main use case. We want to get the redundant firewall. In this architecture, there are many SR-aware firewalls in the SRv6 domain, and it serves to multiple customers. This shows the customer alpha. Alpha's traffic is through the SR firewalls, and the customer beta traffic is through the other SR firewalls. We can serve to other SR SFC service to each customers, and we also acquire the redundancy, or we also use the Anycast seed or fast reroute to this service. Thank you for listening. Welcome your feedback to improve our draft, and feel free to join our work. Finally, this work is partially supported by JSTIC Chronos. Thank you for listening.
Any questions, comments? Anyone read the draft? Yes, good. No, we have Ketan, maybe, no, yes?
I lost the connection.
Yeah, go ahead.
Ketan Talwalkar, Cisco, as a co-author of the BGPLS draft, and we have the service programming. I think it's good that you've done this thing in the hackathon. Look forward to your inputs on the documents and collaborate on them. Thank you.
Thank you.
Thank you so much. Okay, we're going to move on to our next presentation. Okay, Leanne, you're online.
Yeah, I'm online.
Hi, yes, we can hear you. And
Okay, I can see it.
You should have control of the slides too.
Okay, thank you. Hello, everyone. This is Li Yan from China Mobile. And we're glad to do the presentation on behalf of all the co-authors. And this topic is about advertising SRv6 locator information by IPv6 neighbor discovery. As SRv6 is progressively implemented within the networks, we have encountered some scenarios where SRv6 needs to be extended to terminal devices so that they can be incorporated into the whole SRv6 path to realize the end-to-end path programming. And here we list two typical scenarios. One is the host in the data center network, and the other is the CPE in the metropolitan area network. As the picture shows that for the host and the CPEs, they usually do not support the dynamic routing protocols such as IGP. So under these circumstances, SRv6 information can only be advertised through the static configuration. And the key point is that if there are a large number of host devices, the static configuration becomes very inconvenient, especially when the SRv6 on the host changes and the static configuration on the access devices also needs to be updated accordingly. So we need a simple protocol to advertise SRv6 information, such as the SRv6 locator and the capability to do that dynamically. So this draft we focus on the neighbor discovery protocol. This slide elaborates the process of the solution in detail. For the first step, the SRv6 locator is manually configured on the host, and this step is the existing process. There is no modification. And the second step is that the host advertise the SRv6 locator and the capability through the NS and NA message in the neighbor discovery protocol. And the step 3, the access device will learn the SRv6 locator and the capability through the ND message. The fourth step, the access device will re-advertise the SRv6 locator through the IGP protocol. And in this step, I would like to provide additional clarification. For the SRv6 locator, we all know that it possesses two aspects of attributes. One is the normal routing attributes, and the other is the programming attributes. And I think in this scenario, both the two attributes need to be re-advertised to the span device. So as for the routing attributes, the access can achieve this through the existing route advertising mechanism. I think there is no modification and no new things. And regarding the programming attribute, I think that it's necessary for the access devices to advertise it within the IGP. I think that currently this capability is not available in the access devices. So maybe it requires some new additions. And since this is the first version of this draft, and this part is not described in detail in the draft, so I think later we will continue to update this part of the content in the subsequent version. And for the 5 and 6 step, I think it should inherit the existing mechanism without any modifications. And the final step, and is the also the programming action. The controller obtains all the locator information and the capability information so that it can program SRv6 path predictably. So this is the final purpose, I think. And this is the detailed extension for the NS and the NA message. We have we would like to register 2 new IPv6 neighbor discovery option in the INA, and the new options contains the subTLV of the SRv6 locator and the capability. The detail format is aligned with the current definition in ISS or OSPF. And for the SRv6 locator subTLV, it contains subTLV such as SRv6 and seed. And for the SRv6 capability subTLV, it also contains subTLVs such as MSD subTLV. This is the presentation about this solution. And another thing I want to mention is that in the previous one-to-one meeting, we have presented the extension of LDP to realize the same purpose. And we have also received valuable feedbacks and guidance from the chairs and experts. We will also continually optimize the content based on the input. The authors think that the LDP and ND both are widely deployed protocols, and we can choose either based on the deployment conditions. And we also welcome any further discussion on these 2 drafts. And finally, we will follow the decision from the working group.
Yeah, we have several questions here, so we're going to start with those. Cheng.
Cheng Li from Huawei.
Okay.
So I could like to ask a simple question about the motivation. Like, why do you think we should how say expand the SRv6 to the host? Do you have any security consideration of doing this? Thank you.
Thank you for your question. First, I want to clarify that the host is not the normal computer or other device in our normal situation. It's maybe all the devices connected to the network at the endpoint of the network. So we encountered this scenario is in the data center network. So maybe it's a server or something. It can be allocate some SRv6 information to for different applications or something like that. So we want it's very convenient to programming the host to the whole path with SRv6.
Thank you. I see your point, but I think there's some others could like to ask some similar questions, so I leave the time for them.
Okay, thank you.
Tom.
Hello, Yi, and Tom Hill from BT. A similar point, but I think we need to make sure that we're considering the impact of such a solution in the guise of the security considerations for RFC 8402, which states that segment routing should operate within a trusted domain. Whether you're talking about CPE or an Android phone or an iPhone or something in someone's house, or you're talking about a server in a data center, which could be operated by someone else, it could be compromised by someone else. None of these really traditionally fall into any operator's idea of trusted. And so if you combine that with the fact that RAs, neighbor solicitation, discovery and everything like that is particularly promiscuous and not exactly difficult to spoof, I'm not sure that this is advisable in any way. So yeah, I would kind of try to refactor about what we're doing here and why we're doing it and exactly what the security impact of that is, because I have a horrible feeling this will be a particularly easy vector to inject something malicious into your segment routed network. So, thank you.
Eric.
Go on, please.
Okay, yeah, I want to also echo the sort of the security concerns. I'm particularly interested in what the trust model is in the server in the data center. I think I could understand there could be a trust model there, but in like the host connecting to a CPE, that I don't understand that trust model at all. And so the trust model stuff should probably show up in the security consideration section. Also, if you do want to persist down this path, the SRv6 LIO looks like it could probably get quite big. And you'll probably have MPU issues. You might need to consider about what happens when the LIO is exceeds the MPU size. So, and then just some other nits, but anyway.
Suresh.
Thank you. I agree with everything that's been said till now. So it's not clear this is the best way to do the stuff. Maybe some of it is meant for routing protocol or something that I think there's something in routing working group that also does something in this direction. I think Ketan is part of doing that work. So maybe he can chime in as well. That's one thing. And the other thing is the 6-man thing. I know this is complicated arrangement that we need to do, right? The Spring has to express their interest and we go to 6-man and Eric can kind of do that thing, right? But I think that's probably needs 6-man review at some point, if there is interest in going in this direction. But I think it needs to get done sooner rather than later.
Right. So we do need some discussion and engagement on the list. If you have read this draft, please make some comments on the list, support, questions, whatever you want to say about that. Thank you.
Okay,
so we're going
thank you.
to move forward. Thank you, Leanne.
Okay, thank you.
We are going to move on to our next presentation. Feng, I see you. This one. And you should have control of the slides.
Yeah, thank you. So this is a presentation for the SRv6 security on behalf of colleagues from China Mobile and H3C. So SRv6 is only deployed within the trusted domain, as everybody know. Although external security threats has been mitigated, but the risk of internal attacks cannot be ignored, because SRv6 is subject to a modification attack and packet insertion attack as defined in the SRv6 security consideration. For example, all of the network elements in this picture are deployed within a single trusted domain. The black dots represent the SRv6 endpoints, Normally, the user traffic is encapsulated by the head node into SRv6 policy tunnel, passing through P1 and P3 to the tail node, with HMAC verification enabled on the path. That is the SRH header carries an HMAC TRV. Suppose there is an internal attack on P2 who either steals the password or obtains the SRH or some kind of information by packet capture. So this allows the attacker to compose an SRv6 packet which can pass the HMAC verification of the downstream node. Thus, attacker on the P2 can inject any of the SRv6 packet towards the tail node via P3, and that will not be identified, of course. Sorry, there is a typo on this slide. P2 does not here P2 does not exist and should be the tail node. The impact of the attack lies in its ability to bypass certain internal nodes that enforce specific security policies, thereby enable attack to be initiated from internal location and forwarded normally by the tail node. So why does this happen? So why does this happen? It's because HMAC is calculated only for the seed list in the SRH, not for the actual path, the packet traverses. This is a security risk that deserves attention. So here is a proposal. To verify actual paths that packet traverses, we need to incorporate information about each endpoint the packet passed through into the packet. Second one is we do not expect that the information incorporated into the packet expand with the length of the path. So our proposal is to calculate the HMAC of the destination address at each endpoint rather than HMAC of the entire seed list. That is kind of a fingerprint on each of the devices on the path. So at the same time, as each endpoint, the HMAC value of the destination address is calculated and then added to the HMAC value in the packet's TRV. The result is then written into the packet. So the result is a summary of all of the HMAC values on the path. So in this way, we obtain the fingerprint information about the entire path traversed by the packet. As a tail node, we can then verify the information. That makes us be able to easily identify the packets that do not match the actual forwarding path. From implementation perspective, on each node, the computational work is a little bit reduced because we only calculate the HMAC of the destination address, not the entire seed list. And we also need to store that value to the packet, which I think that will not significantly impact the forwarding delay. The benefit of this method as follows. The first, I think the password used for its HMAC calculation does not need to be global significant across the entire path. It can be different for each node. Second, the HMAC in the packet will be updated at each endpoint, allowing us to verify to do verification on any endpoints of the path. That is either on the tail end or on the intermediate nodes. Since there is a SDN controller, so the configuration work will not be that complicated. complicated. The thirdly is the approach will have a similar overhead in terms of the packet size with HMAC solution specified in RFC 8754, which specifies SRH, because all of the HMAC values of each node are aggregated into one. Lastly, similar to the RFC 8754, the path verification configuration is also highly flexible and can be configured on only a subset of node. So, but there is question. Maybe people will ask a question: why does this sum up of the HMAC method works? Because this actually not a new technology. This has been there for more than 10 years in the blockchain. For example, the Merkle tree in the Bitcoin. So it has been verified. So consider there is a HMAC theory in SH no longer has bit available to represent a different verification method. We have defined a new theory within the SH, considering that HMAC may be if we reuse HMAC theory defined by the FC, then that will have some back compatible problems. So and we also define an algorithm ID to enable in the future we can have different of the algorithm to overcome that case that's confidential may be compromised in the future. So I think that's all of what I want to talk in this presentation.
Thank you. We have one question here, Tal.
Hi, Tal Mizrahi, Huawei. The HMAC used in SRH, I think, is intended mostly to verify that the SRH wasn't modified. And I think what you're trying to do, correct me if I'm wrong, is you're trying to verify the path, which is something different. It's a different objective. And you may want to look back at IOM proof of transit, which had kind of a similar objective. And back in the day, we tried to consider something similar to this, kind of an onion ring approach where each node would add its own HMAC, and this could be verified at the end. But the complexity was just prohibitive. So at the end of the day, we decided it wasn't a good idea. So it's something worth looking back at.
Thank you.
Yes,
yes,
thank you,
yeah,
go ahead.
Thank you. Yes, I think that purpose is similar with what you mentioned.
Yes, the other thing you may want to look at is this, of course, has a SR specific application, but in general, you would want to verify, say, a whole IP path, for example. Also, this is one of those drafts that has a very close relationship to 6-man, since you're proposing an enhancement to 8754. So yeah, let's discuss on the list. If this is the path we want to follow, we need to go to 6-man anyways. But I believe that the comment of looking at this in a wider way is important as well. Thank you.
Yeah, thank you.
Okay, we're going to move on to our next presentation, which is Paolo. This is a presentation on benchmarking.
Good morning, Paolo Volpato, Huawei, and I'm presenting on behalf of the co-authors you see listed here. So basically, the scope of this presentation is to introduce to Spring the work that has been developed in the benchmarking working group on the benchmarking methodology of the segment routing packet forwarding capabilities of a network device. Okay, you see basically the draft scope summarized here. So fundamentally, we leverage the the benchmarking capability of the RFC, defining how to test a network device in the lab environment. So we expanded the work done by RFC 2544 and the other work defining the benchmarking methods for IPv6 and MPLS. That was the base of our work. And the work was expanded to include both the forwarding capabilities of segment routing, MPLS, and SRv6. Now, without, let's say, giving too many details, we do invite to read the draft and comment. But basically, you see that the work expands the foundational capabilities defined in RFC 5695, so MPLS, benchmarking capabilities. The work was expanding to include the characteristics of segment routing, as I mentioned, both SRMPLS and SRv6, including the capability of dealing with compressed seeds. The picture you see listed, represented here, comes from, let's say, RFC 5695, but I said the methodology was expanded to take into consideration the basics of segment routing, and in particular SRv6. So differently from the MPLS benchmarking, we recommended the use of at least 2 labels or 2 seeds, if you prefer. And we also proposed to repeat the test, trying to identify the maximum seed depth carried by a packet. The idea clearly is to, let's say, simulate, for example, traffic engineering cases and having the possibility of steering the packet flow on different paths. The tests are dealing with the underlay capability, but in doing so, we, let's say, we consider different roles of a node. So it could be the end-to-end, the destination node, or the transit node. So the tests are repeated based on the characteristic of the, let's say, of the node and the functional requirements under test. What is important to highlight is that in this draft, we don't consider the service layer. So for example, as you see listed here, in layer 2 or layer 3 VPN are not in scope of our draft. That is the scope of a different draft developed in a benchmarking working group, but it's something different from ours. Now, where we stand. The work started around 3 years ago in benchmarking WG. The draft was adopted after IETF 119, so we progressed after that with the evolution of the test description. I would say that the main version addressing all the comments was version 02, so presented in October. And after that, I would say most of the work has been completed. And considering that, so we believe that the description of the methodology is stable enough. So we like to receive the comments from the segment routing experts in Spring. That's why the chairs of BMWG cross-posted the draft to Spring and SRv6 ops, so looking also at the operational side of the problem. And we really appreciate if you can give a look at the draft and provide comments. The reason why I'm asking that is because we believe that the draft is almost ready for the WG working group last call. So we like to receive your feedback, as well as to see if there are any public testing activity that we can reference in our draft. Speaking with the people in benchmarking, we do know that some testing activity are ongoing, but in some cases they are not public, for example, because they are done internally to the organizations of a carrier or a network operator. But if you're happy to provide some details, we are also happy to include them in our draft. And when I say reference to public activities, is not I'm asking for specific details. For example, somebody has done a test and vendor A is performing better than vendor B. No, it's just the adoption of our methodology to, let's say, to do the test. Also, could be important to highlight if other methodologies were used. And that's also something that could complement the description in our draft. So that we hope to receive your feedback, and once this is completed, we plan, as I said, to move to the last call. And I would say this is all. Thanks.
Thank you, Paolo. So if anyone can please look at this draft, make some comments, that would be very much appreciated by BMWG. Thank you.
Thank you.
So we're going to move to our last presentation, which is a presentation on IPFix export. Yalu.
Hello, I'm Yalo from ZT, and this draft is about export of XFP6 path segment identifier information in IPFix. And so some background information. So IPFix is the IP flow information export protocol, and it serves as a means for transmitting traffic flow information over the network. So an important component in IPFix is the information element. It is a description of an attribute that may appear in an IPFix record. So for IPFix of SRv6, there's already an IFC 9487. In this RFC, new IPFix information elements is defined to identify a set of information related to SRv6, including most of the fields in SRH. And for the segment list in SRH, two information elements are defined in this RFC. Both encode the segment list information starting from segment list 0. So, but the whole segment list is not always the best key to is not always the best key identifier. So the reasons are similar as in the SRv6 path segment draft. So the first is when there are many sets in the list, the size of IPFix message would be large, so it is inefficient to collect and analyze it. So, and the second is if different SRv6 policies use the same segment list for traffic steering, it is difficult to distinguish the traffic flow of different SRv6 policies. And third is an SRv6 path may not be identified by the segment list carried in the SRH if we use a reduced mode. So in this case, the first list is not present in the SRH. So a quick recap of SRv6 path segment identifier. So it is identified to define an SRv6 path, and it is encoded as the last entry in the segment list in SRH with the SRH P flag set, and it will never appear in the destination address. So in this draft, our proposal is simple. We defined a new information element to carry the SRv6 path PSID. So for SRv6 path identify purpose in the IPFix message, and for the flag field, so it is already defined. So how to operate? Mainly the procedures, you should follow the procedures introduced in the SRv6 path segment draft. So in order to generate the flow records with a PSID, the metering process need to understand the P flag. It did not to support the real function of the path segment, just know the meaning that the P flag. So the second is only when the P flag is set, the metering process can capture the last entry to get the PSID. The third is the analysis node should be aware of which SR path the path segment identifies. So welcome feedbacks and comments, and we tend to ask for adoption in the OPSA WGUI after we get it reviewed in spring. That's all. Thank you.
Go ahead.
Yeah, Tony from Huawei. I think the draft is just really useful, so I support the draft. Thank you so much for your work.
Thank you.
So again, this is a draft that is not a spring draft. So please review it on the list. And if you support it, of course, go support it on the other list as well. Thank you so much. Thank you, everyone, for finishing on time. As I said, we have to be out of here in the next 4 minutes. Please keep in mind that we need engagement on the list for everything. So promote your draft, tell people about it. More importantly, review other people's drafts, make comments about them, because that is what we really want. We want everyone talking to everyone else. As we said before, we will have an interim meeting in May focused on the security document, but we will probably have time for other discussions there as well. So we'll let you know about the dates and other logistics in a little bit. Thank you so much. And we'll see you in May 1st, yes, and then in Madrid, yes.